With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hi guys, now we'll solve a question on complex numbers. Okay, the question says suppose p is a polynomial with complex coefficient and all even degrees. Okay, if all the roots of p are complex non-real numbers with modulus 1, then prove that p1 belongs to real number. That doubly implies p minus 1 belongs to real number. That doubly implies means if the right statement is true, then the left statement should also be true, and if the left statement is true, then the right statement should also be true. Okay, that means double implication. Fine, we can prove this very easily. Let's say our polynomial is p and it's a function of x, and it's written in form of a x raised to power, what should I write here? I should write 2n because all the degrees are even, so I'll always write in form of 2n. So here b into x raised to power 2n minus 1 plus c into x raised to power 2 into n minus 2. I'm writing 2 in front of all these n minus 1, n minus 2 because we have to just get the even degrees. So until and unless I won't multiply 2, this won't result in even. So I'm multiplying this deliberately. Okay, so dx raised to power 2 n minus 3 up till I don't know how many terms, but it's infinite terms. Okay, and it says if p1 belongs to real numbers, that means I am putting 1 in place of x now. This is p1. It belongs to real numbers. Let's put 1. If we'll put 1, then it would result in a into 1 raised to power 2n plus b into 1 raised to power 2 into n minus 1 plus c into 1 raised to power 2 into n minus 1 up till infinity. Fine. And if we'll solve this, we'll simply get a plus b plus c plus d up till infinite. Okay, because 1 raised to power 2n or 1 raised to power 2n minus 1 is always equal to 1 because I am multiplying 2 with each exponent. That means it is getting even, and 1 raised to power any even quantity is always 1. Fine. Next thing, next it is saying you calculate p minus 1. Okay, one thing here to notice that if you put 1 raised to power 2n or minus 1 raised to power 2n, it is not going to make any difference at all. You know why? Because 1 raised to power even is same as minus 1 raised to power even. So the effect that p1 produced will be produced by p minus 1 as well. So let's write it down. Minus 1 raised to power n, b minus 1 raised to power 2n minus 1 plus c minus 1 raised to power 2n minus 2 up till infinity. And this will again be written as a plus b plus c plus d up till infinity. That means we are getting the same answer for p1 and p minus 1. What does this mean? This means if you calculate 1 and get an answer which is real coefficient, then you would be asking how it could be real if the complex coefficients are there. There must be any cancellations. Like if I write 3 plus 2 iota as a and 3 minus 2 iota as b. However, a and b are complex coefficient, but their summation is a real coefficient because this imaginary part is getting cancelled out. So this is basically 6. So in the same way, a plus b plus c plus d up till infinity would be summing up somehow and giving a real result. Similarly, p minus 1 would be also giving this real result. So we can just say if p1 is true, then p minus 1 is also true, and if p minus 1 is true, then p1 is also true, because putting 1 and minus 1 won't make any difference in the variables, right? So we are done with this question.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.